We are minutes away from the launch of NASA's Lucy mission to the never-before-explored Trojan asteroids. Lucy's long journey to space begins today, but her story actually started years ago. It took a team of scientists and engineers many years to plan where Lucy would go and what she would have to do. Then, Lucy's engineers had to build her out of individual parts and put her together like a puzzle. Lucy had to go through tough physical tests to prove she was mission ready. How are you holding up, Lucy? These are the vibration and acoustic tests to make sure that Lucy won't lose any screws during the shaky launch on a rocket. Lucy wasn't quite ready just yet. The engineers still had to be sure that she was prepared for the harsh environment of space. They chilled Lucy to freezing temperatures, then warmed her up to scalding hot temperatures in the thermal vacuum test. Sure, those tests weren't easy, but they prepared Lucy for the long adventure ahead. We're glad you can join Lucy on her adventure to explore the Trojan asteroids. Now, let's get the journey started. You might be wondering, where is Lucy off to? Yes, the Trojan asteroids. These are a population of asteroids in orbit around the Sun, about as far away as Jupiter. It may seem far away to you, but our Lucy spacecraft is a capable explorer and ready to make the trek to her targets. Lucy is aiming to visit asteroids in both of these Trojan swarms on her 12-year mission. The pull of gravity from the Sun balances the pull from Jupiter to keep the Trojan asteroids in these two groups. Due to the Gravitational Balancing Act, these asteroids have been in these orbits for billions of years. It's still quite the challenge to explore these targets. However, our intrepid explorer is ready for her mission. Aren't you, Lucy? Ah, of course. You'll be the first spacecraft to visit these asteroids. I can't help but wonder, though, why choose these asteroids in particular? I see. The scientific evidence says the Trojan asteroids are leftover material from the formation of the planets. Right. These asteroids hold vital clues to understanding the history of our solar system. It's just like a treasure hunt. What you discover could teach us about the history of the solar system and how the planets, including Earth, came to be the way they are. I won't hold you up any longer. Safe travels on your journey. Be sure to write home and tell us all about it. So you're finally getting on your way to your asteroid encounters. Say, which Trojan asteroid are you visiting first, Lucy? Euripides. You still have quite a long journey before you get there. So, why don't you tell us what you already know about this first Trojan target? You're right, we don't know much about these objects. Just yet. Keep in mind, our only observations of these asteroids have been from a great distance away, from telescopes back here on Earth, and with the Hubble Space Telescope. Scientists have used all kinds of different telescopes to get basic information about Lucy's Trojan asteroid destinations, where they are, how they're moving, how big they are, their general color, and, if we're lucky, a very rough idea of their general shape. But nothing compares to actually flying right past these asteroids and getting a close-up view. And that's where Lucy comes in. Yeah, exciting. This is the first close-up of these worlds. You'll be learning as much as you can about these Trojan asteroids and giving us a new glimpse into what these distant worlds are. Now get some rest, Lucy. It'll be a long journey before you get to your first destination. Nope, Lucy. Still a little way to go before you get to your first Trojan asteroid. But it looks like you're coming up to the main belt asteroid, Donald Johanson. Right, this'll give you a chance to check in on your instrumentation before you get out to the Trojans. This first instrument is called LaRalph. It will take color images of the Trojan asteroids using visible and infrared light, helping scientists map craters and mountains and figure out what the asteroids are made out of. Next, this is LLORI, the Long-Range Reconnaissance Imager. This camera will provide the most detailed images of the surfaces of the Trojan asteroids to help scientists figure out what's been happening since our solar system formed. This is LTES, the Thermal Emission Spectrometer. Basically a touchless thermometer. It will measure the temperatures on the Trojan asteroid surfaces to tell scientists whether the surfaces are rocky or dusty. Lastly, you couldn't get the job done without your tracking cameras or the T2 cams to make sure the asteroids are always in view. And the high-gain antenna that lets you communicate with Earth. The scientists back at home will use your radio signals to measure the mass of each asteroid as you fly past it. Right, Lucy, how could I forget? You also have 2 huge solar panels to give you electrical power as you fly out to the Trojan asteroids. Farther from the sun than any previous solar-powered mission. Just a bit longer now before you get to your first target. Rest up and get ready to put all of those instruments to good use. I'll check back in with you once you make it out to your first Trojan asteroid. There it is, Lucy. Your first Trojan asteroids. Euripides with its small moon Keta. Earth to Lucy! Remember, you need to take a lot of images of Euripides and Keta in not a lot of time before you're zooming off to your next target. Make sure you get all those images for us. It's beautiful, isn't it? And we're past. Whew, that was quick, right? Get any good data? That's great to hear. Can't wait to see them. Just send them back to us here at Earth. We have so much to learn from what you've already sent back to us, and you're just getting started out there. There's still 5 more Trojan asteroids to explore on your 12-year journey. Each one has a different story to tell about the history of our solar system. Next up is Polymele, a mere 21 kilometers or 13 miles in diameter. Afterwards, you'll be zooming by Lucas, which rotates at an extremely slow rate, with each day being about 18.5 Earth days long. Afterwards, you'll be on to Oris, which might be rich in organics and carbon. Lastly, you'll be on your way to a twin pair of asteroids, Patroclus and Menetius. These asteroids, relatively unchanged over 4 billion years, will give us a glimpse of our solar system's distant past. With each flyby of a Trojan asteroid, you'll be looking at time capsules from the birth of our solar system over 4 billion years ago. Lucy, what your observations tell us about the composition and properties of the Trojan asteroids could give us clues about how Earth came to be. Absolutely. Carry on your journey, Lucy. And don't forget to call